In the previous video, we successfully built eye and nose detectors. In this video, we're going to see how to perform principal components analysis. Principal components analysis, PCA, is a dimensionality reduction technique that's used very frequently in computer vision and machine learning. When we deal with features with large dimensionalities, training a machine learning system becomes prohibitively expensive. Therefore, we need to reduce the dimensionality of the data before we can train a system. However, when we reduce the dimensionality, we don't want to lose the information present in the data. This is where PCA comes into the picture. PCA identifies the important components of the data and arranges them in the order of importance. You can learn more about it with this documentation. It's used a lot in face recognition systems. Let's see how to perform PCA on input data. Let's go to the editor. Here we've created a new Python file, pca.py, and we have imported these two packages in the beginning. Let's define 5 dimensions for our input data. The first 2 dimensions will be independent, but the next 3 dimensions will be dependent on the first 2 dimensions. This basically means that we can live without the first 3 dimensions because they do not give us any new information. Let's create a dataset with these features. Now create a PCA object. Let's fit a PCA model on the input data. Next, print the variances of the dimensions. If a particular dimension is useful, then it will have a meaningful value for the variance. Let's set a threshold and identify the important dimensions. Just like we discussed earlier, PCA identified that only 2 dimensions are important in this dataset. Now let's convert the dataset from 5-dimensional set to a 2-dimensional set. Let's go ahead and run the code. So, you can see now the output giving the variances in decreasing order and the number of useful dimensions, and also the shape before and after. Great! In this video we have reduced the dimensionality of the input data by performing principal components analysis on it. In the next video we'll perform the kernel principal components analysis in a similar way.